In the next 6 minutes, you will be introduced to Renaissance, Mazor Robotics guidance system for spine surgeries, and learn how it works. Renaissance includes a workstation, advanced software, guidance unit, and several mounting options. Spine surgery with Renaissance consists of 4 basic steps: preoperative plan, mount, 3D sync, and operate. The first step of a Renaissance procedure starts before entering the operating room with preoperative planning on a computer. The patient's CT scan is uploaded to Renaissance's advanced software to create a detailed 3D model of the patient's spine. This enables you to accurately visualize the patient's spinal condition and plan the ideal, customized surgery in a virtual 3D environment. Renaissance preoperative planning provides many advantages, with better preparation for each surgery. Anatomical challenges such as hypoplastic pedicles are identified. Trajectories such as in-out-in can be planned, and implant sizes are optimized for better bone purchase and strategic placement. Renaissance's interface allows you to review and modify this plan in axial, lateral, and AP views until you are fully satisfied with the location and purchase of the implants, or trajectories from other procedures such as vertebral augmentations and biopsies. All preoperative planning can be performed on your personal computer with Renaissance software installed. To enhance the procedure's safety, you can review the preoperative surgical blueprint in a virtual video mode on Renaissance's planning software. This displays implants slice by slice on the CT in all 3 surgical planes, as well as a full 3D review of the surgical blueprint. Now let's see how we accurately execute the preoperative surgical blueprint with Renaissance in the operating room. The preoperative surgical blueprint is uploaded to Renaissance. Then you select one of Mazor Robotics' mounting options, depending on the clinical indication as well as your preference. All mounting platforms are rigidly attached to the patient's spine to assure that maximum accuracy is maintained throughout the surgical procedure, even if patient movement occurs. The most commonly used platforms are the clamp mount and multidirectional bridge mount. The clamp mount is attached to a spinous process. A bridge is then mounted onto it with 2 K-wires above and below, locking the spinal segment, thus maximizing stability. While the clamp mount is most commonly used for scoliosis and deformity procedures, it is also suitable for minimally invasive surgeries. A 3 cm incision is made to insert the clamp mount, which can later be used for decompressing and inserting an interbody. The multidirectional bridge mount attaches to the railings on both sides of the bed and a K-wire to a spinous process. Its bridge can be translated laterally, in parallel to the patient's spinal column. The multidirectional bridge mount is particularly well suited for minimally invasive surgeries, since only a single K-wire is used to rigidly attach it to the patient. Once the mounting platform is in place, we are ready for the next step. To execute the CT-based surgical blueprint, it is necessary to match it with the patient's spine and the mounting platform attached onto it. In order to indicate the mounting platform's spatial location on fluoroscopy, a 3D marker is attached onto it. 2 fluoroscopic images of the 3D marker and spine are taken in AP and oblique views. Renaissance's software then automatically matches these intraoperative images to their corresponding location on the preoperative CT. This 3D sync process registers and synchronizes the CT-based surgical blueprint with the patient's spine and mounting platform, allowing the software to precisely match Renaissance's guidance unit relative to the patient's and preoperative CT. Each vertebra is registered separately, independent of anatomical landmarks, so deformities, previous operations, or changes in intervertebral spaces do not affect accuracy or performance. Once the mounting platform and patient's spine are matched and synchronized with the surgical blueprint, you can start working with the guidance unit. To begin the surgical procedure, you first select a target vertebra from the preoperative plan. The software will show you where to attach the guidance unit on the mounting system you selected, as there is more than one option on each platform to increase your surgical reach. Then, It will direct Renaissance's guidance unit to the exact position according to the surgical blueprint you've created. You will be shown also which arms and tools to use to reach your planned trajectory. You will pass your surgical tools and drill guide through the cannula, which will keep you on target while you work. This process continues until all trajectories are reached and implants safely placed in their planned location, with 1 mm accuracy without additional fluoroscopies, thus saving time and minimizing radiation. This whole process ensures the highest level of precision for each surgical action. Mazor Robotics technology has been clinically validated by independent studies. It enables highly accurate spine surgeries with less radiation, even for minimally invasive and complex spine procedures. Thank you for watching how Renaissance works. We invite you to join the success of surgeons worldwide who have used Mazor Robotics technology in thousands of surgeries. Join their ranks as a leader in spine surgery.